Right, welcome back everyone. We're actually getting quite close to the end of this topic that we've started. I'll also remind you that we did some of the trigonometry, right-angled trigonometry, toward the tail end of chapter 1. And then since trigonometry started off chapter 2 with non-right-angled trigonometry, then I thought, let's just go ahead and combine them together. So there's only two topics left to do, and then we're going to have to stop and check out an assessment. This particular one today is dealing with areas of non-right-angled triangles. You will, of course, recall when you were younger that the area of a triangle was always a right-angled triangle. It was 1/2 base times height. And if it wasn't a right-angled triangle, we would try and manufacture the height by drawing an altitude line in. So basically from the top of the triangle down to the base at a right angle. And you would sort of force the issue. Well, what if you don't have that? Well, there's still a way to do it. And now here's our formula kit, and you'll see a new formula there in 3.2 at the bottom. Area of a triangle is the area, capital A, and that's not to do with the vertex or corner of a triangle A. The vertex is 1/2 AB sine of the angle C. And if you were to envision that, what you have is, since capital A is one of the corners, then side A is across from it using the regular naming protocol or custom of a triangle. That means these sides B and C would be surrounding it. Now, obviously, in this case, we used vertex C. So if C was here, you'd have A and C on the sides. So basically, it says it's 1/2 times 2 of the sides times the sine of the angle between the two sides. So it's got to be what we call a contained angle, or what this book where I've got this from calls an included angle. It's in between. So you have to be very, very clear about that. We're going to practice that now. But the angle here, C, must be between the two sides. And if it's not, you're going to have to try some really creative ways to make sure you get it into that format before we try and use that formula. And of course, you can rotate around the triangle, and all of these are possible. If you were given the angle A, then it's sides B and C, the containing sides that you would need. If it was angle B, then it's A and C, and if it's C, then it's A and B. Okay, now, what we have here is a series of 6 slides with 6 questions. And I want to point out that in this first question here, number 1, in each case, the angle is included. The 40 degrees in question 1A, the 82 degrees in question 1B, and the 125 degrees in question 1C. In all cases, they are included angles. And I'd like you to try those. And when you're done with those, you can hit pause and... you can hit pause now. When you're done with those, you can hit resume, and then we'll take a look at the rest of the question. So hit pause now. Okay, we're back, and now we're going to take a look at this one here. Now, what happens if some information is missing? Well, obviously, we've got a great feature on our calculators that can help us with that. Please hit pause, try this question, and I'll show you the answers in a moment. All right, once again, now they're giving you a question that doesn't give a diagram. You're going to have to work out a diagram for yourself from the wording of the question. It's an important skill for an IB math student to be able to take the written word, decode it, and come up with a visualization. So hit pause now. I'll show you the answers soon. Okay, now it says a parallelogram. Now you might be thinking, hey, hang on, a parallelogram, that's not a triangle. Well, actually, a parallelogram is only made up of 2 what we call congruent or identical triangles. So you can, if you get the diagram right, you can see how triangles play a role in working this out. So hit pause, give it a try, and I'll show you the answers soon. And again, a rhombus is a type of parallelogram. So like the last one, it has a role to play. You're going to be a bit careful and creative the way you use that angle information that's given in the question. All right, hit pause. Answers are coming soon. And the last question here, you've got, well, it's a triangle given, and I'm going to go ahead and let you just work on that one. All right, hit pause when you're ready to move on, hit resume. Okay, and here's the answers to the questions that you had. So you can go back now and maybe take a shot of that with your phone and go back and check that you got your answers correct for the preceding 6 questions. If there's any problems, make sure you ask me, and I'd be delighted to come over and help you with that. Okay, anyway, so there it is, a little formula. We're going to be in exercise 2C of our textbook now. I'm not doing all the questions, just a few to get us going, make sure we understand it. Oh, some questions expressed in exact values, fantastic. And it goes to, I think it's up to 6, but our questions here is section 2C, questions 1, 3, and 4. You'll notice that there's a gap coming up, and that is 2E. It is a non-essential topic. We will be doing 2D, which is more about sectors and arc lengths and areas of sectors, and then that will close it out, and that will be our time next time. Okay, after you've tried the 6 examples in the PowerPoint or in this video, then you go ahead and try exercise 2C, and we'll get ready for tomorrow.